Right. So when I first started this driver board project, um, they do say when you start something, it's always best to start something off on the right foot or whatever. Well, it's 2020 and I started on the wrong foot because everything was going wrong. So do you remember this circuit, the first one I did, which was using the latching um, transistors, and look how complicated it became when I was designing this. And I had the DN2540. Incidentally, I went and blew two of those up, blew the gate up on two of those today because maximum minus volts is 3.5 volts, and I went and put a bit more than that in. I think it was only about 12. Anyway, I just got sick of it. I thought, oh, I've had enough of this transistor, this MOSFET. It's driving me nuts. And the circuit was getting more and more complicated, as you can see. So anyway, that's the first one I did, and anyway, it didn't work properly according to the way things would work. So I scrapped it. Then I moved on to this one, which was more simplified, and two separate channels, one to trigger the circuit on, one to trigger the circuit off, and I was a little friendly DN2540 again there with the our transistors and the filter cap and everything. And yeah, then I realised when I did some further tests on it on the oscilloscope, it wasn't latching. Oh dear, this thing will latch if you just probe it with a probe and it's not connected to anything. But as soon as you introduce the low impedance circuit into it, nah, it wouldn't do what I wanted to do. Oh, everything went wrong today. I'm not kidding you. Some of my PCB designer software files suddenly became 0 byte, which means I lost some of my components when I'm trying to design the circuit. And that's another thing that went wrong. So today has been one of them days where everything goes wrong, and I've been recovering from backups and everything else. So in the process of all of this, I did manage to complete the new circuit diagram. Now look at this one, see how complicated it is. Right, and I finally tested this one, and it's a lot simpler. Well, it's got the same part at the beginning, which is what we want for the two channel start on state and off state. This is the Mark III. And I've been testing this all day and it works very well. So this is the one I'm going to go with. This is what I'm going to build, and it looks quite big, but it's not big at all, because if you look at the component count, there's very few. I've just spaced everything out so you can see clearly, but there's none of dies back to back. That's the same as before. And our ground, which is through a resistor there, which is common AC ground. This is an AC circuit, you see. And then it's rectified into the positive pulse, which is the on state, and the negative pulse, which is the off state. And it's simply achieved just by reversing the coils so that you have a negative pulse instead of a positive pulse. So anyway, this is the part that I've been working on today, and it's a lot simpler. And oh look, there's no DN2540 anymore. Oh yeah, I had enough of it. I got rid of it. So we're just using another BC537. I'm actually using 536, sorry, 556, sorry. So we've got it right down to this, which is a lot simpler. There's our latching circuit, and we use quite a high impedance on the input to trigger it, and it works. I've been testing it all day. So we use non-polar there, so we don't have as much leakage if possible. But so we have 10 meg on the input, and it's very sensitive, and it works. That's why I've got a 10 meg resistor there, which triggers this one. This latches that onto that transistor, and we have higher values on here, so it's 100k there. I've tried to keep the impedance quite high, so we've got more gain. And the BC547's down there, and that's the ground. We've just got some biasing resistors to make sure everything stays latched when it's latching, and that's 10k there between the collector of the PNP and the base of the MPN. And then there's 1 meg there that goes basically down to ground. That's just, well, that doesn't have to be there actually, but it helps. It does seem to help balance things out a bit. Actually, is it 1 meg? I think it's supposed to be a 1k. No, it's a 1k. Sorry, that's right. Yeah, that's right. So it's 1k. Then we've got our Zener diode, because that's to get rid of a problem where this LED was staying partially lit. So rather than trying to sort a problem out up here where it was partially biased, which I can't really do, I've got 100k in series with the Zener, and the Zener basically crops off 4.7 volts so that this output transistor latches on and switches more effectively and doesn't keep the LED partially on. So that works. Anyway, I've been running it, and so this is the next circuit to be building now. So finally, after all that, we've got that. I mean, that, if you look in the red box, is less than what got there in the red box. And well, the red box isn't on this one, but it's the same area, general area, but it's a lot less than what we would have had here, which is including all of that and all of that down there. So it would have been all of this before, which didn't work. But this does work. Yes, it works quite well. Actually, I don't know if I can show you. I haven't got my oscilloscope running at all at the moment, but it's basically this little bit here, these 3 transistors. Now, if I turn it on, and if I get my bias, I've got a resistor on the end of which is to simulate a weak signal. And if I just tap that, I can't see what I'm doing now. Is it that one? I turned on. Oh, there we go. Right, there we go. So it triggers it. That's the on, and that's the off. On, off. I'm just touching with this, tickling with this resistor. It's not very reliable because I'm dirty contacts on the resistor leads, but I haven't got the diode circuit. The diode circuit is actually over here. I've got some diodes over here which I can trigger when I've got AC going. So I can send AC in one diode and it turns it off, and AC in the other diode and it turns it on. So if I take this lead off here, you'll see there's 2 germanium diodes here, and they're both connected to this resistor. And then this resistor goes through this trimmer pot, which is basically simulating the circuit. Then there's a capacitor there, then it's going through that 1 meg resistor across this other capacitor, then to the base of the transistor. So yeah, it is working. I don't know if I can show you it when I simulate with just one end. I'd have to basically pull down. Let me just try and do this with my finger. If I wet my finger, well, I'll lick my finger now and touch these diodes. I can't do it. Right, let me try and turn it off. Ah, it went off, look. Can I turn it on with a positive? So that lead off there. It's very sensitive. No, I'm touching the wrong thing. Always happens when you're on camera, doesn't it? Trying to send a positive signal here now. Of course, my fingers aren't very conductive. Well, put my clip lead back on. Oh, wrong one. Where's the... Oh, yeah, there you go. It's back on, look. That's how sensitive it is. I need to put that back on here. See, I just touched that and it went off. That's how sensitive it is. So I've got my signal going in. This is from the coil actually. Anyway, it works. I'm happy with that. So I don't want to blow anything up. So I'm gonna try to unravel these wires. Right, so that's basically all there is to it, really. Anyway, I've got to sort the circuit board out probably in a day or two, actually, because I've got some restoring to do on the computer now, because some of my library files got messed up and I don't know how. I don't know if the auto update failed or what, but some on the software, the software that was trying to update, because I'm an XP, so it might be that, I don't know. I tried to disable it because I don't want it updating, because it'll corrupt everything, and that's probably what happened. So anyway, oh my god, my battery's pretty flat on the phone. I'll have to go anyway, so yeah, I'll try and get something sorted out in a couple of days. But oh, one more thing, I was running the coil on the MOSFET driver today. This big chunky coil around. These were for generating power actually, but I used it to actually send power out, and I hooked it up to the MOSFET that's connected to my board, and we had it pulsing really nicely, and it actually consumed about 1 amp when it was pulsing, with the time delay and everything. But I wasn't driving anything, I wasn't driving my generator thing with it, I was just pulsing it and checking the flux on it, and it was pretty strong, so it definitely works. Yeah. So I've just got to get it all circuit boarded. Okay, that's it for now.